My name's Tim Percoski, and I'm a chemistry teacher and physics teacher as well at the Metropolitan Learning Center Magnet School. The students in this lesson are in AP Chemistry. It's a very diverse group of students. There are many students in here who are considering a pursuit of a career in the healthcare field or the science field. And there are other students in the class who simply took the class because they wanted to take an AP class and really wanted a challenge associated with taking an AP class in order to prepare themselves adequately for college. Today the students were working on an inquiry experiment in which they were confirming the idea that the entropy actually drove the spontaneity of the experiment. And while it was content related for sure with respect to, we're learning the laws of thermodynamics, it was really more of an inquiry lesson where the students were given a task of trying to develop their experiment, and in developing the experiment, trying to find ways to come up with data to either confirm what they expected or to refute what they expected. You were designing an experiment using that equation there to prove that this chemical reaction is entropy driven. Is it possible you'll prove that it's not entropy driven? Is it possible that that will be what the data demonstrates to you? Absolutely. But you're going to be able to make sure that you collect all those data so you're able to work your way through it and figure out exactly what it is that this data shows you. Okay? All right, if there are no other questions, get with your team, start reading through what's going on, figure out how you want to go about this, and we'll go ahead and get started. I'll be bouncing around to give you guys a hand and kind of steer you on course and make sure everything's going the way it's got to go. Okay? All right, thanks. I'm a firm believer that in the inquiry-based model, the conclusion doesn't happen at the end of the experiment. The conclusions are happening concurrently and ongoing. In a true inquiry model, the questions are being asked throughout a lesson, and the answers to those questions are coming up as a result of the lesson going on. So it's constantly asking questions and answering questions for the students as they go. And so as I'm working with the students and as I'm cycling around the room and trying to gauge the students' understandings, I really begin to ask those questions. What are you learning? How do you know that you're learning it? What does this tell you about the experiment that we're doing? What does this tell you about your learning? How does this relate to the other things? And what I'm often finding is that the students are able to give me not only quick responses to those questions, but they're also able to give me very accurate and well thought out, articulate answers. So that demonstrates to me that they're really invested in the inquiry model.
So we have a value for this, we have a value for this, we get a value for this, but then how does that give us the value for this? That's what I'm confused
You put T
about.
inside, plugging everything back into the equation.
Like if we thought about 100 Kelvin.
But then this would be 0.
important to fully mix the solids together, but I don't know if that counts for this experiment.
I think it might have, but I think we missed we had it because we saw that huge drop, but then we might have already.
That drop could be
The endpoint when the reaction's done is the endpoint when it cools down to room temperature, when you reach that endpoint, you know what I mean? But would it give you that data you're looking for?
As I overheard Mr. P, they didn't see a change in theirs, and he mentioned the amount of water that they used. So even though we did use 75, which is under 100 that it suggests, we might benefit from using less.
I do a lot of coaching when I'm doing an inquiry type of an investigation or an inquiry type of an experiment. And the nice thing about that is that because I've got many different groups, I have to differentiate between groups myself. So the type of coaching might be different. And I always tell my students, in an inquiry type of an experiment, I will never purposely steer them off course. My goal is to steer them back on course by giving them questions to think about, and so that they can modify what they're doing and really think about what they're doing to try to arrive at some end result that's going to be usable for them. So does it look profoundly different than it did before? Is it looking liquidy? So what might you need to do?
The bottom is.
Okay, the bottom might be. So what might you do now to try to hurry that reaction along? Think about kinetic theory, kinetic molecular theory. Yeah, we might have to stir, and we might have to really stir it up a lot to really get that stuff moving around, so that if we get that stuff moving around and we change that surface area and really get a lot of surface area going on, then we might be able to get a reaction taking place. Think about that concept of rolling up, if you roll a boulder up a hill, yeah, it takes energy to get that boulder rolled up the hill, but as soon as you get to the top of the hill, what happens? It spontaneously goes down on its own. Same kind of thing here. Inquiry is something that I embed into every lesson. It could be as simple as types of questions being asked. It could be a homework assignment. It could be a demonstration that is done. It could be any wide range of things. The idea of doing an inquiry investigation or an inquiry experiment, though, is not something that we can invest the time to do every day. It's a process. So if the students are seeing the process and working through the process over and over and over again, it doesn't have to be a daily process where they're going through an entire experiment. I personally try to embed one inquiry experiment in each unit that I do. And the nice thing about it is that by the third or fourth unit, the students have gone through the process 3 or 4 times, and they buy into what I'm trying to do with them, and they're a lot more susceptible to going through the process the way that I want them to go through it, so that they're able to really come up with a good return on their investment of time.
What I do want to talk with you all about now is just some specific things that we talked about with each group, and have you guys clarify for the rest of the group what you got out of that, okay? What do we know about the specific heat of water?
It has a high specific heat.
Very high specific heat relative to other things. So what does that mean in terms of raising its temperature or lowering its temperature for that matter?
Maybe small amount of water.
Or
High energy.
high amount of energy or high amount of heat, right? So tell me what you did in your experiment to combat that as you worked your way through it, because this was one of the groups that changed the amount of water, and I want you to sort of articulate to the class why you did that.
Really working with the student and encouraging the students and trying to get them to buy into what it is that you are selling them. This idea of inquiry is so crucial in order to make this work for those challenging students who maybe are having a hard time with it. I find so many times the students are challenged and don't want to do it because they're worried about getting the wrong answer. And I think if the emphasis is placed on the process as opposed to the answer, then students are able to more easily buy into it, because no student wants to do poorly. So if you let them know that at the end of the day, going through the process is the right answer, it doesn't matter what the final number they come up with is. There is no wrong answer.
Those in the test tubes. All right, nice job. Okay.
When inquiry is done, I really think that it helps a student's confidence in asking and answering questions. It really helps them to move their brain forward and to get them to think about things in a way that they haven't thought about them before. When inquiry is done best, really new questions come up along the process. And I think that can be applied to everywhere, whether it's in a science classroom or whether it's in the real world. The idea that if something comes up that you are not anticipating and you're able to reason out and come up with answers to that, or some kind of a conclusion or a new question that might help to drive a direction that you're trying to go as a person, then I really think there is a strong benefit to it. You don't get that without practicing inquiry, without practicing asking and answering questions. You can't get that by answering questions on worksheets and end of chapter questions in textbooks and those sorts of things. Those are things that you can only learn by going through processes and trying them and failing at them. And when you fail at them, asking a new question so that you can continue to move forward. Inquiry is ongoing. There is no endpoint to inquiry, and I think it really helps students to become well-rounded learners through their entire process as they go forward through all of their learning from their young ages all the way up through their higher education.